I'd like to start by telling you a little bit about what this competition is all about. The Heavy Civil competition is put on by the Associated Schools of Construction, and our problem sponsor is Granite. Basically what Granite does is they give us a set of plans and specifications and ask us to conduct a full quantity estimate to determine the cost of the project. In addition to this, they basically want us to determine how to put this project together, both phasing and scheduling and any other work-related tasks. To give you a little summary of this year's actual project, it was the addition of 4 new on and off ramps from the Moana lane to the I-580. The schedule for this project will be 53 working days, which is very tight. This is because the city actually wants the on and off ramps to be completed by Black Friday. The indirect costs for this project are $650,000 with a margin of 12%. This will come out to a total bid of $6.9 million. Now I'd like to pass it off to Fabian, who will tell us a little bit about the scheduling.
The schedule for this project is really condensed. Like it was mentioned previously, we have to build it within 53 working days, which is pretty much 3 months. The reason for this is that the owner wanted us to meet 2 different milestones, and if we didn't meet those, we had to pay liquidated damages. The highest one went up to $20,000. This really tight schedule created pretty much 100% critical activities within it, and besides being really tight, we also had to take into account traffic control restrictions from the state of Nevada, where we had to maintain traffic at all times. We were only allowed to do night shifts, but maintain traffic at all times.
For the roadway excavation item on this project, there are some requirements that are found in the special provisions, including excavating to subgrade without disturbing the subgrade surface, and we must compact the subgrade to 90% in all locations which do not receive geogrid, geotextile, and drain backfill. We broke this item into 6 separate operations, including layout using a GPS survey crew to set the locations of our saw cut. When we go in, we saw cut to get a clean line to the new pavement. We use a Cat 350 excavator with a breaker attachment to demolish the existing AC, which is spoiling directly behind it, with a Cat 980 loader loading into end dumps and hauling to disposal. Next, we will rough grade using the Cat 350 excavator and a 140 blade to fine grade. And in the locations which require the 90% compaction, which only accounts for 21% of the total item, we use a 10-ton smooth drum roller. Finally, the excess base and native material will be loaded and hauled to disposal. Here are the 3 different pavement sections which we have for this item. The 17-inch depth is the only one that requires the 90% compaction, and these 2, the 29 and 32-inch depth, have the drain backfill, geogrid, and geotextile, which John will talk to you about next.
Thank you, Alex. So as you can see here, we're going to be going over the soil stabilization for this project. We ended up using 2 different types of soil stabilization, one for horizontal and one for vertical. You can use these separately or together, and based on our soil test, we decided to use both. It's stopping the vertical and the horizontal shear of the soil, the geotextile, and the geogrid. They're both basically applied in the same manner. They're using 20-foot wide sections with a spreading machine, as well as some laborers to hold down the ends, sew them together, and to stake them at the ends to tighten them, followed by the drum roller to flatten out any inconsistencies, creases, anything like that. They're done immediately following the structure S because we don't want to tear or damage any of the material. So the only key note in the geotextile and the geogrid is just that the geotextile is specifically mentioned not to be woven material based on the amount of traffic that will be going on top of it while we do our drain backfill and ag base. So I'll turn that over to Matt Beluski to do the drain backfill and the ag base.
Thanks, John. After soil stabilization, drain backfill and aggregate base must be laid. Aggregate will be brought on using end dump trucks. The backfill will be spread using a Cat 140 along with a skip loader. Depth of aggregate must be checked by a grade checker. Laborers will be used to spread the aggregate in areas where there are space restrictions. The aggregate base will be brought in using 15 cubic yard belly dump trucks. The first operation will be to spread and compact the base. Throughout these activities, we are required to run a water truck to manage dust and maintain aggregate moisture content. Now I'll pass it off to John.
All right, thank you, Matt. So as you can see here, the next topic we'll be going into is the plant mix surfacing. Basically, that's just our hot mix asphalt on site, and it's going to be going on top of the ag base. The reason for this is because it's a good binder for the top of the ag base to hold everything in together and to create a suitable surface for the PCCP paving that we'll be doing next with Moana. So as you can see here, there's just a couple small keynotes that we had to do with this. The first is on the first day of the mix, we must produce one trial mix for conforming to the specs to deliver to the owner. If we fail that, then we have to wait 3 days before we go again. Also, we must cease production if we have 2 tests fail. It's very key to have the proper mix, especially in this type of climate. And then the other keynote is just that it's the PG64-22, which is a significant property because it's the only type of oil that we're allowed to use for our HMA in the area of Reno, Nevada because of the temperature changes. So based on those, we needed to do it excessively fast and do it right after the ag base. And I will turn it over now to Mona, who will do the PCCP paving.
For the Portland cement concrete pavement on this job, we had 2 different depths, an 8-inch and 11-inch, totaling about 23,000 square yards. The 8-inch was along the I-580 ramps, while the 11-inch was along Moana Lane. The southbound off-ramp, along with the part along Moana Lane, needed to be completed during Phase 1 in order to open them up to traffic, while the remaining ramps were going to be installed during Phase 2. We utilized a Gamaco GP 2500 slip-form paver to place, consolidate, scree, and float finish the concrete in order to minimize our labor costs and save money overall. On the next slide, you can see our pour plan, which included 12 different pours that occurred over the 2 phases. Some of the steps that we took to ensure some quality control and assurance were maintaining that the air content was up to spec, that the slump was less than 3 inches, which was a requirement for the paver, that the water to cement ratio, the compressive strength, and the placement and coverage for the dowels and tiebacks were per spec. We're also going to ensure that all of our personnel have proper training and education on both the machine and the process of the slip-form paver to ensure that it is up to par. Next, I'm going to pass it over to John for the island paving.
Thank you, Mona. So as you can see here, we're going into the Class AA concrete, which is called island paving. So as you can tell by the title, it includes all the islands that we did throughout the project, and they're all different medians. And because of the type and nature of this project being a diverging diamond, there was multiple islands that were incorporated in this project to help with traffic flow. The only key parts about all these islands was, one, that they were a specific color that had to be signed off on by the owner, as well as the city, and then 2, the type of concrete with the pozzolan percentage, as well as the aggregate, all had to be sampled and tested by the engineer and approved by the county. So as you can see in the next 2 slides, these are just the areas that we had the regular island paving. Through here and here, they went through the center of the project for about a mile, and they were separated by some of the other paving that we had on hand. And as you can see here, this is where it turns into the special island paving. So this is where you go past just the color and the type of concrete. You actually go into stamping. And so all 4 of these islands had to be stamped with a specific canyon stone random interlocking pattern. And that actually had to be submitted as well and improved by the engineer as well as the owner. Other than that, they were really as basic as an island as you can get, besides the components that actually went into the mix design for these. So now I will pass you off on to Jordan to conclude our project.
In conclusion, our total project cost came out to $6.1 million. With the addition of our indirect costs and our margin, the total bid came out to $6.9 million. After analyzing all the risks associated with this project, we've determined that it is going to be very profitable and we plan on doing a very successful job on it. Now I'd like to finish by showing you a 3D rendering of what the project will look like upon completion.
We'll start by heading eastbound on Moana, where you will be directed to cross diagonally beneath the interstate. Here you will have an opportunity to make a free left-hand turn to northbound US 395. You can see this is unsignalized, unlike the current configuration, where you have to stop on both sides of the interchange and wait for a left-hand turn. Next, let's demonstrate heading northbound on US 395 to head westbound on Moana Lane. First, you'll stop at a traffic signal. Then you will traverse beneath the interstate on the left-hand side of the road. At the crossover, you will be directed diagonally back onto the right-hand side of the road. The diverging diamond interchange is a very unique design that has been successfully implemented across the country with tremendous success.